Today we are going to learn about implementing market basket analysis with Python. You'll gain hands-on experience with Python libraries to perform market basket analysis efficiently. Welcome to this tutorial on implementing market basket analysis with Python. In this session, we'll explore the practical aspects of performing market basket analysis, a key technique used to uncover relationships between items in large datasets. Understanding these relationships can drive decisions in retail, marketing, and more. Python, with its powerful libraries, simplifies the complex tasks involved in this analysis. By the end of this video, you will be equipped with the skills to set up your Python environment, utilize essential libraries, and execute market basket analysis to derive actionable insights. Let's dive in. Before we dive into market basket analysis, it's crucial to have a robust Python environment set up. Begin by installing Python through Anaconda, which offers a comprehensive package for data science. Anaconda simplifies the management of libraries and dependencies. Next, set up Jupyter Notebook, a versatile tool for writing and sharing live code and visualizations. For those preferring an IDE, options like PyCharm and VS Code are excellent choices, offering features tailored for Python development. Install essential libraries like Pandas for data manipulation, NumPy for numerical operations, and mlxtend for machine learning extensions. Finally, verify your setup by running a simple script to ensure all libraries are correctly installed. With this setup, you'll be ready to perform efficient data analysis.
Understanding the core libraries is essential for any data analysis task. Pandas stands out for its powerful data manipulation capabilities. It allows you to easily load, preprocess, and explore data with its intuitive data frame structure. NumPy complements Pandas by providing support for large, multi-dimensional arrays and matrices, along with a collection of mathematical functions to operate on them. mlxtend is a lesser-known but equally valuable library, particularly for market basket analysis, offering tools like association rule mining and frequent item set generation. Familiarize yourself with basic Pandas commands like read_csv, head, and describe, NumPy's array and arrange, and mlxtend's a priori and association_rules functions. These libraries are the backbone of the analysis we'll be performing. With a solid understanding of the key libraries, it's time to load and preprocess our dataset. Using Pandas, datasets can be loaded effortlessly using commands like pd.read_csv. Once loaded, it's crucial to clean the data. This involves handling missing values, which can be done using methods like fillNA or dropNA. Transformations such as converting data types and normalizing values ensure that the data is in an analysis-ready state. Preprocessing is pivotal as it directly impacts the quality of the analysis. Visualizing data distributions using plots from libraries like Matplotlib or Seaborn can provide insights into the dataset, revealing potential issues or patterns. This step sets the foundation for a successful market basket analysis. Now that our data is prepared, we can focus on generating association rules. Association rules help identify interesting relationships between variables in large databases. We'll start by generating frequent item sets using mlxtend's a priori function, which identifies sets of items that appear together frequently in transactions. With these item sets, we can derive association rules using the association_rules function, specifying metrics like support, confidence, and lift. Writing a script involves defining these functions and interpreting their outputs, which include metrics indicating the strength and reliability of the rules. Adjusting parameters such as the minimum support threshold can refine the analysis, targeting the most impactful rules. This script serves as a powerful tool for uncovering insights from transactional data. Visualization is key to understanding the results of our analysis. Tools like Matplotlib and Seaborn are invaluable for creating impactful visuals. Start by plotting the support, confidence, and lift of association rules using scatter plots or bar charts. These visuals not only enhance comprehension but also facilitate the communication of findings to stakeholders. For instance, a heat map can effectively display the strength of associations across different item sets. Interpreting these visuals involves identifying patterns, anomalies, or trends that might not be evident from raw data alone. Effective visualization transforms data into a compelling story, making it easier to act upon the insights derived from the analysis.
To solidify our understanding, we'll apply our analysis to a sample dataset. Consider a retail transaction dataset containing items purchased together. Begin by loading and preprocessing the data as previously discussed. Once the data is prepared, generate frequent item sets and derive association rules. Throughout this process, interpret the results to uncover insights, such as which products are often purchased together. This case study highlights real-world challenges, like dealing with an imbalanced dataset or sparse transactions. By addressing these, we can refine our approach and enhance the robustness of the analysis. The lessons learned here will be invaluable when tackling more complex datasets in professional settings.
Efficiency is crucial when working with large datasets. Optimizing your Python scripts can significantly enhance performance. Start by ensuring your code is clean and well organized, utilizing Python's inbuilt functions and libraries, which are often optimized for performance. When dealing with large datasets, consider using data structures like NumPy arrays, which consume less memory and allow faster operations than traditional Python lists. Reducing computation time can also be achieved by parallelizing tasks or using efficient algorithms. Adopting best practices, such as profiling code to identify bottlenecks and optimizing them, ensures that your scripts run smoothly and efficiently, even with extensive data. Implementing market basket analysis in Python can present several challenges. Common pitfalls include memory errors, often caused by loading large datasets entirely into memory. Avoid this by processing data in chunks or using memory-efficient data structures. Ensuring data integrity is another challenge. Always validate and clean your data to prevent errors in analysis. Exception handling is key to creating robust scripts, so use try-except blocks to manage unforeseen errors gracefully. Debugging techniques, such as using print statements or Python's PDB debugger, can simplify troubleshooting. Finally, improving code readability through clear, concise documentation and consistent naming conventions aids in maintaining and scaling your scripts. As we conclude, let's recap what we've covered. Market basket analysis is a powerful tool for uncovering insights from transactional data, and Python, with its robust libraries, makes this process efficient and accessible. You've gained practical skills in setting up a Python environment, using key libraries, and executing analysis scripts. These skills open doors to various applications, from enhancing retail strategies to optimizing marketing campaigns. The journey doesn't end here. Continue exploring and refining your techniques, and you'll find endless opportunities to apply these insights in real-world scenarios. Thank you for joining us, and happy analyzing.